Oh, yes, indeed. I mean, I was talking about the flushing time. And we use the concept of water age. Okay, if you don't know what water age is, go back to the lecture, which explains it. Okay? So what's shown here is the salinity field. Okay, and this one is salinity field, in later late winter where you see an evidence of the outflow or so. But anyway, you see the salinity field, but you also see the water age. Okay, and just have a look at it, and you can see that the higher the salinity, the older the water. Okay, so let's focus on Spencer Gulf, and there's something very clear from this distribution. Colors are salinity, the lines are water age. Let's have a look. Where is the 1 year? Let's get the pointer on. Try. Where's the 1 year transition zone? Here's the 1 year transition zone. Can you see it? 1 year means anything less than 1 year is flushed within a year. Okay, so you learned about that every winter there's this outflow driving an inflow, but it cannot flush the entire Gulf because there's only a limited time. So what it does, it comes in and only flushes the Gulf halfway through. Okay, and this happens every year, and that's why the flushing time or the water age is less than 1 year. Okay, this is what you can see. You can see also that the age is lower on the western compared to the eastern side, because on the eastern side you have an outflow of older water. Okay, so now in the upper Spencer Gulf, in this region here, you have water ages exceeding 1 year. Again, this makes the area very special. Also in Upper Gulf St. Vincent, you have flushing times exceeding 6 months in the upper regions. These areas are more or less excluded from the annual, the seasonal flushing. It's a sheltered, secluded region. It's almost like a lake. It's not the swell waves don't reach in there. It's hypersaline, and the salinity actually reflects the low, slow flushing of the. And this is what makes the upper reaches of the Gulf so special. And this is linked to the cuttlefish. Okay? All right. Just to finish off this part of the lecture, we can just compare salinity with water age in the Gulfs and can produce a plot. Okay? And you can see the link between salinity and age. And it's actually not very difficult to understand why you have that general link, because without flushing, the salinity would just increase because you have evaporation. In excess of evaporation, it removes the fresh water, salt water stays behind, and it gets older and older and older. Okay, so the higher the salinity, the older is the water. Why you have now a difference between Gulf St. Vincent and Spencer Gulf? Gulf St. Vincent generally has a younger water, so it has a more rapid flushing, if you like. Why that is, I couldn't tell you. Okay, this is just an academic little detail. Okay. So, all right. So now, but there's more you can do. So now you have a model that can simulate tides, wind-driven flows, which are not that significant in the region. It's more the density-driven flows that are density-driven effects. So you have a model. What else can you do with a model? Okay. What you can do is you can predict the dispersal of floats, of particles, of floating material. And I want to show you some examples.